So the same has been explained once again. Let's x is equal to 0.333. Multiplying both sides by 10, we get 10x is equal to 3.333. Now we come to subtraction. After checking that the decimal expansion is same in both the equations, we get 9x equal to 3 and x equal to 1 upon 3. So I hope you've understood this, and this seems very interesting. We have to practice more questions to understand this. I've already told you that both rational and irrational numbers can be represented on a real number line. We know that how do we represent a terminating decimal on a number line? That's very easy. But if it's a non-terminating decimal or if it's an irrational number, how to represent it on a number line? Suppose we have 2.6666 or 2.665, then how do we represent it on a number line? We know that if I have a number line and I have to insert 2.5, 2.5 can very easily be inserted between 2 and 3. 2.25 will come between 2.5 and 2.25. 2.75 will come between 2.5 and 3. But if I ask you how to represent, suppose 2.61, 2.62 or 2.665, obviously it will be between 2.5 and 3. And this is a property of a real number line that infinite number of numbers can be inserted between two real numbers. We have a special method for representing such numbers on real number line, and that is visualization. Visualization of numbers. That means if there are greater number of digits after the decimal point, still we can represent it on a number line by the process of magnification. So visualization of numbers by the process of magnification. And what are we magnifying? We are magnifying the number line. That doesn't mean we are using a magnifier in real. We are using a method which will expand my number line and help me to magnify it, to visualize it better. So by the process of magnification. I hope all of you are super excited to see what is this magnification. Let us find out. Let's start with an example. Suppose we have to visualize .665 on a number line. Very obvious, 2.665 lies between two numbers 2 and 3, but exactly where? Had it been 2.5, it would have been easier for me to locate, but if it's 2.665, that means there needs to be 100 divisions on the number line, which is practically not possible. So let us see how do we do it. Starting with, we know 2.665 is a number greater than 2 but less than 3. So my first two endpoints would be 2 and 3. And 2.665 is a number closer to 2.6 and 2.7. So if this is my 2.5 between 2 and 3, 2.6, and this is suppose 2.7. So obviously 2.665 will lie between 2.6 and 2.7, but where? For that I need to magnify this part. I need to magnify this part. I cannot expand the number line on my piece of paper because I have limited space. So I need to magnify it. So what kind of magnifier am I going to use? I am going to use a method which magnifies this portion of the number line. So for that I need to go to step 2. In step 2, I'll only take this particular part of the real number line with endpoints as 2.6 and 2.7. But how do we magnify it? Very simple method. In the first step, I have only one digit after the decimal point. In the second place, you just add one more digit to the decimal place by inserting a 0. This divides my number line into 10 equal sections, starting from 2.60 and ending in 2.70. So obviously in between I'll have 2.61, 2.62, 2.63, 2.64, 2.65, 2.66 and 2.67, 2.68, 2.69. So this is my 2.66, 2.67. My target number 2.665 lies between 2.66 and 2.67. Again, I need to magnify this part of the number line because the number which I want to visualize lies between 2.66 and 2.67. So what was the first step? First, I started with one digit after the decimal point. Then I went to two digits after the decimal point, and to magnify it, I'll collect this portion of the number line and jot it down in the third step by increasing one more place of decimal. So how do I do it? Yes, what will be my two endpoints now? My two endpoints will be 2.66 and 2.67. Here my two endpoints were 2.6 and 2.7. So here I write down 2.66 and here I write down 2.67. But yes, to visualize it and to visualize it better by magnification, I need to add 1 0. Obviously, perfectly 2.665 will fit in here. 2.665 will lie exactly between 2 points. This is the midpoint of 2.660 and 2.670. So my 2.665 will lie between these 2 points, which I can see very clearly. So this is the process of magnification. This is the process of magnification, and we have to show all the steps to visualize a number. So let's recall it once again. What we have learnt in magnification. Going by my same example, 2.665, if I have to represent 2.665 on a number line by the method of successive magnification, how will I do it? First, I'll think of that where does this 2.665 lies on a number line and where can we locate it between two integers. Between two integers, 2.665 can be located between 2 and 3. So, on the number line, the first step I have to mark 2 and 3. Next step, I have to divide the number line into 10 equal parts. If I divide it into 10 equal parts, I can see between 2 and 3, there are 2 points, 2.6 and 2.7. So, obviously, 2.665 will lie between 2.6 and 2.7. This is my first number line. 2.665 lies between 2.6 and 2.7. So, I have to expand this part of the number line, 2.6 and 2.7. So, in the next step, my two endpoints will be 2.6 and 2.7, which I will write as 2.60 and 2.70. So, 2.6, as we can see, lies between 2.65 or 2.65 lies between 2.6 and 2.7. Again, we divide 2.6 and 2.7 on another number line. 2.6 and 2.7, when divided into 10 equal parts, I'll get 2.66 and 2.67. So, again, I need to magnify this. Again, I have to, as you can see on the screen, I have to magnify this part with endpoints as 2.66 and 2.67. So, it would be convenient if you add one more 0. it will help you to divide the number line into 10 equal parts. So remember, in the first step, 1 digit after the decimal point. In the second step, 2 digits after the decimal point by inserting a 0. And in the third step, 1 more digit. Every time we keep on increasing 1 0 to the decimal point to increase the number of decimal points. So, first step 2.66 and 2.67, when it is magnified with 2.66 and 2.67 as the end points, I make it 2.660 and 2.670, and my 2.665 will lie exactly between these 2 points. I hope this method of magnification is understood by you and you found it interesting. So let us visualize one more number to understand it better.